in Introduction to Statistical Learning, and we are in Chapter 6, Question 9. Okay, so so what we're going to do here is we're going to use the data set that is called college and try to predict the number of applications that are received using the other variables in the data set as predictor variables. Okay, so to do this, we are going to apply just basic least squares regression, and then also apply some of the methods that we've learned in this chapter that hopefully provide a better fit. Okay, so we'll go through those one at a time. I don't know how much depth I'll go through with all of this, and so much of it is code, and there's a lot of things to go through, and it would just be too many concepts. So, but we'll see what happens here. Okay, so the first thing we want to do is to get our data loaded and to split it into training and test sets. Okay, so we need to install the ISLR2 package and load it. All right, and then I need to call up the college data set. I'm just calling it D. Okay, and then there's a variable in there called private. That's a factor, but the factor causes some problems down below, so I'm just kind of reformatting the factor as an integer here. Okay, so to split it into training and test sets, so I decide how much of the data I want to call training, so I'll say 80%, and that equals this many rows of our data or observations. Okay, so then I randomly sample that many rows. And the ones that get sampled are part of the training set, and those that don't get sampled are part of the test set. I can also break down the dtrain and the dtest in terms of just the predictor and outcome variables. So xtest, or xtrain, xtest, ytrain, ytest. Okay, so there's the code for all that. Okay, so the first thing that we'll do is to just use regular old least squares and find the test error. So I'm going to run least squares on the training data, okay? And then to find the error, I will predict the test data, and then find the average difference. Oh, that should not be there. That should not be there. And then find the average difference between what's predicted and the actual value there. Okay, so if I run all of that, I should get, let me, ls test error. Okay, so I get a value. All right. So now to part C. So now we're going to modify that regression by using ridge regression. Okay, choosing the best lambda value, the best lambda value, which is telling us how much to penalize our fit. Okay, so when we run this, we get all of this, but the important part here is going to be the ridge error, okay, and that is right here. Okay, at the end we'll come back and collect all of these values, so don't worry too much about how big and ugly they are right now. All right, so now we go on from using ridge regression to instead using lasso. Okay, so we'll use lasso to fit that same thing. Okay. Give it a second. All right, and so now we have the error for lasso. All right. Okay, and so now we will use PCR, and then the next one will be PLS. And so let me just quickly run these. This will run it for us, and then we'll get the error down here. Maybe I should say what that error is going to be. Okay, so there's our PCR estimate for the error, and then we do the same for the PLS. And so that will run it, and then we'll get the test error here. Oh, again, I forgot to print that guy. Okay. Just to kind of break down this code a little bit, sorry, I should have done this originally. So So for the PCR and PLS fits, so just kind of the steps of what's going on. So first we set up our equation here, okay? So again, we're trying to find apps regressed on everything, and for everything else, we can just put that period there in the training data set, okay? Well, what we get at the end is the cross-validation error, right? So we're saying for the validation method, we're using cross-validation, and we get the cross-validation error for using 1 to up to 17 different predictor variables here. And so we want to go through and find the smallest error and cross-validation error. And so it happens to be with 17 variables there. Okay. So with m equals 17, we now predict the test error like this. Okay. And so we find the predictions on the test data. Okay. And then subtract that against what was actually found and square it and take the average, and then we get the error for that. Okay. Now that same process is repeated for the PLS, but it's it's a different command. Okay. And now we want to compare the errors of all of these different methods here. Okay. So here I'm just gathering all of the errors, and then we'll plot it, and then we'll we'll sort them from least to largest here. Okay. So this is our test errors, and interestingly, so I think on different runs you might get different values here, but interestingly, this is the ridge regression is doing the worst here. Let me go make sure I haven't made an error. Okay, so I don't see any errors, so that's interesting. But so in this case, given my particular data split at least, we see that ridge regression is actually doing the worst, which is a little bit interesting to know. But everything else is doing pretty much, pretty similar in this particular case. So yeah, I don't know what else to say about this one, so we'll call it good.